Now we're going to tackle how, knowing ions, we can write the formula for ionic compounds. So on this slide, just to give us some different ways of representing the transfer of electrons and the result of electrons, we're just going to review this, and then we'll get into the process of how would I write a formula. All right, so the first on the upper left-hand corner, this is just two illustrations of how you might represent an electron transferring. So this first one that I'm drawing the arrow pointing at, in this illustration, as you look at it, they have a sodium atom and a chlorine atom on the left of an arrow. So that would be like the atoms are starting out. And they show that you have one electron transferring from the sodium to the chlorine atom. Now, what you'll notice on the product side is they have ions that are forming. So here's the ions. So that's one thing, because now the sodium, instead of having 11 electrons, now only has 10. And then the chlorine atom on the product side, instead of having 17 electrons, now it has 18. So one thing you might notice from this illustration is that the cation is smaller than its parent atom. And this is always true when atoms lose electrons, their ions become smaller. And then the chloride anion, when it gains electrons, it becomes larger. And that is also true when atoms gain electrons. Their anion is larger than the original atom. So these two ions then with opposite charge would be attracted. And we'll look at what we can imagine the structure in the lower left in just a minute. But let me also show you here, let's just look there. At the second line, they're using the Lewis structure for atoms to show the transfer of electrons. And so notice the sodium on the reactant side has one valence electron, and the chlorine atom on the reactant side has 7 valence electrons. Then they use the blue dotted arrow to show how the electron from sodium is transferring over to the chlorine atom. And the result, or the products, we now have a sodium ion. Notice it has no valence electrons around it because it lost its valence electron. So there's no more dots, and it has a plus sign. And now the chlorine atom now is an ion. It has 8 dots around it because the one that transferred over. And again, you get the positive and negative charge. So this first in the upper left-hand corner is just an illustration of what we mean when we say the transfer of electrons. Now, I know you're thinking, do I have to know this for the test? I will mention that second representation showing how electrons are transferred using Lewis structures, I have asked something like that on the extra credit. So I have asked you to show how would you represent the transfer of the electrons using Lewis structures. So I have asked something like that as one of the extra credit options. Now, on the bottom right-hand corner is just the crystal lattice, which I mentioned before in a previous video. And that just shows you that when we're talking about ionic compounds, and writing their formulas, we're just writing the ratio of the ions inside the lattice structure. So ions, all the positive and negative will attract to each other. And so it makes these structures that have multiple ions all in a ratio based on their charge. So even though we're going to be writing formulas, for example, sodium chloride, I would write the formula as NaCl. It's not because there's one sodium ion and one chloride ion all by itself, but it's because within these lattice structures, the ratio of the charges is 1:1. The second lattice structure is just another way they just draw lines instead of making them all close to each other. I will not ask you to draw a lattice structure for an ionic compound, but I do expect you to know that ionic compounds exist as ions in a lattice structure. So let's get down now to how are we going to write formulas. So previously we learned how to predict charges, but positive ions and negative ions don't exist independently of one another. They're going to be together in compounds. So let's see how we're going to write the formulas for those. Now on this slide, I have rules that are written in words. I find that the words make no sense until we start doing examples. So as you do the words, if you read through them, they don't make sense. Start practicing some, like follow the examples, and then come back to the words, and I think they'll make a little bit more sense. So when we're writing formulas for ionic compounds, the first thing we need to do is know the charges of the anions and the cations. And that's basically what step 1 is telling you. You got to know the ions. It does have this, which I've mentioned multiple times now, that metals form cations and nonmetals form nonmetals form anions, the negative charge. So that's what we have to do. We have to have ions. And then we're using something called the principle of electrical neutrality. I'll write that here. You don't need to give it back to me. But basically what it's saying is we have to put the two ions together so that when we add their charges, it equals 0. So we have to put the charges together so there's no extra positives or negatives. So that's what so step 1 says you get the ions. Step 2 says we're going to arrange them in a way that the charge equals 0. Step 3 says how we're going to actually write them down. So we can figure out how many we need, but how are we going to write it? Okay, important. The positive ion is going to go first. I want to circle first. Cation first, which cations are the metals. So the metals first and the anion second. So that's the nonmetals. So our formulas and our names for ionic compounds are going to be metal followed by nonmetal. How we're going to tell people how many of each ion we need are the subscripts. So if we need more than one ion, we'll put a subscript telling how many we need. We will not write anything if we only need one. Okay, so let's get an overall picture. I'm going to do some examples, and then you might want to come back later and look at these words again. So first of all, we're going to figure out what our cation and anion are. Second of all, we're going to figure out how many we need of each one of those so the charges equal 0 when we add them together. And then in that process. So third, we're going to write it together as a formula with the metal being first and the non-metal being second. Now, I will mention we don't usually think 1, 2, 3. Usually we're going to go like it's all going to come together kind of as one big process. So let's do some examples. Now, I have a periodic table here because I wanted to write the charges here so you can see why I'm getting the charges I'm getting. All right, so there's a couple ways that this could be introduced to you, or this could be asked, or you could be asked to do this. One might be that you're given the two elements. So it could be something like, they could say lithium and fluorine. So you might be given the metal and the non-metal. Now, because that's so ingrained in me that the metal comes first, even in my examples, I always write the metal first. Okay, so it's not a mistake. The metal always has to come first. So if they give you two elements and want to know what their formula would be, the first thing I'd have to do is find the ions. So lithium's in group 1A, so that would be a Li plus. Fluorine is in group 7A, so that's an F minus. So those are the two ions. And then, so to put them together, I have to look at their charges. Well, if you have a plus one and a minus one, I only need one of each of them to get them to cancel, because a 1 plus and a 1 minus would cancel. So I would just put one of each. So 1 doesn't need a subscript. And this is the formula of the compound. And then sorry for the pause. Someone is at my front door. So then the other thing I want us to practice here, so we have the formula of a compound. It's 1 to 1 because it's a plus 1 and a minus 1. How we would name the compound is you just name the ions. So this would actually just be named lithium fluoride. Because remember, the metals are named the same as the element, and the non-metals or the anions are named with an IDE ending. Okay, so ions use the charges to find the formula. So I'm going to try another one, and I'm doing 3 in a row that have something in common. So this one I'm going to pick calcium, and I'm going to pick sulfur. So if they just give me the element names, then I would have to go, and calcium is in group 2A, so it's a 2 plus. This is the ion. And sulfur is in group 6A, so it's a 2 minus. So those are the ions. And then I need the formula of the compound. So I look at the two charges, and a 2 plus and a 2 minus, they have the same number, right? So a 2 positive would just cancel out a 2 negative. If I added that together, it would equal 0. So again, in this situation, I only need one of each. So this is the formula of the compound. And I'm only writing the words next to it because I want you to understand what you're being asked if you get asked a question. Okay. And then if I wanted to name this one, this would be calcium sulfide, because the calcium ion is just called calcium, and then the anion sulfur, its anion is called sulfide. Okay, I have one more, and then we're going to talk about what they have in common. And you'll understand once I get there why I'm doing this. So I want to do aluminum and nitrogen. which I don't even know if this is really a something that would form very readily. Some of these things that we're putting together, the ions may not be likely compounds, but it doesn't matter. We can still practice all of our ions. Okay, so aluminum is a 3, so it'd be a 3 plus. Nitrogen is in group 5A, so that's a 3 minus. Now again, a 3 plus and a 3 minus, I only need one of each of these because a 3 plus and a 3 minus would just cancel each other out. It looks really weird, but it would be ALN. So again, this, when they ask for ions or formulas of ions, that's what they're talking about. If something asks for a compound, or sometimes it just says the formula, and if it has two things, they're asking for the formula of a compound. Now this one would be aluminum ion is just called aluminum, so it's aluminum. And then nitrogen ion is nitride. Now, if you look at the 3 examples that I have, the lithium and the fluorine, calcium and sulfur, and aluminum and nitrogen, these 3 examples all have something in common. And that is that the value of their positive charge, so the number on their positive charge, was the same value or number on the negative charge. So it was a 1 plus and a 1 minus, or a 2 plus and a 2 minus, or a 3 plus and a 3 minus. And so what we need to take away from this, and this will always be true, is if the number on the positive charge, the cation, is the same number on the negative charge, the anion, the ratio, or how many you need, is always 1 to 1. Okay, I don't have to think about it. If I have a 2 plus and a 2 minus, no matter what the elements are, it's a 1 to 1 ratio. 3 plus, 3 minus, 1 to 1 ratio. Now, the reason I'm mentioning this, and the reason I did 3 of them to show you this, is because when they're not 1 to 1, I have a little, I don't know if it's a shortcut, it's not really a trick, or I guess it's a shortcut to figure out how many you need. But if you apply the shortcut to a 1 to 1 ratio, you can get the wrong answer. So let's take a look at some more that are not having the same number and how we would do that. Whoops, I thought I had another, let's see, 3. Where's 4? Okay, so that's an example. I'm going to take off the stuff on this slide and reuse this slide, or I'll just go to the end. See if I can add a slide. Okay, I'll just do this one. It's okay. The program I used to make this is not super sophisticated. So let's do, made me go. I keep hitting the button. Sorry. There we go. All right, so I'm going to give us some charges and we're going to practice this. So let's say I have a barium and a bromine. All right, so those are my charges, and I can use math to think about it, and these are pretty easy to see usually. But if I have 2 positives and only 1 negative, then it's going to take 2 bromide ions in order for this to cancel. So it will take 1 barium and 2 bromides. Right, because barium would have a 2 positive, and then bromide only has a 1 negative. So to cancel, I would need 2 of these, right? So it's going to take 2 bromides to equal just the 1 barium. And then we would name this barium bromide. All right, let me think of another one. I'm going to show you the trick in just a minute. I want to do a couple. I'm going to think of another one. Let's say we have potassium. And I want potassium to be with, why don't we say nitrogen? So potassium ion is a +1 and the nitride ion is a 3 negative. So those don't just cancel because you have to have the same positives as you do negatives. So since nitride is 3 negative, it would take 3 potassium total in order to have 3 positives, right? Because each one is 1 positive. So it's going to take 3 potassium to cancel out 1 nitride ion, right? And if I just think about like with little charges, like a nitride is a 3 negative. That's it. Well, a potassium is only a 1 positive. So to get 3 positives, because they have to have the same positives and negatives, mathematically, it's going to take 3 of the potassiums to cancel out that 1 nitride. And so it takes 3 potassiums and 1 nitride. This is called potassium nitride. Remember, the metals are named the same as their element. The nonmetals, the anions, have an IDE ending. Okay, one more. I'm going to show you the trick, and then I'll give you, I have a couple slides where you can practice. Okay, so the other one, I want aluminum and oxygen, oxide. Now, this one is not always as easy to see because 3 and 2 don't go into each other just like a 1 and a 3 or a 1 and a 2. So then I have to start thinking, okay, what would a 3 and a 2 have in common? And they would have 6 in common, the number 6. So to get 6 positives, I would need 2 aluminums, right? Because I would have a 3 plus and a 3 plus. That would be 2 aluminums. That would be 6 total. To get 6 negatives, since oxygen is a 2 negative, I'm going to need 3 of those, right? So I have 1 negative, a 2 here, and a 2 here. And so when I think about the charges, 2 3 pluses would give me 6 positives, and 3 2 negatives would give me 6 negatives. So I need 2 aluminums and 3 oxides. So the process, and whether you could use little pictures or however your brain works through the idea that you need the same number of positives as you do negatives. Ultimately, that's what has to happen for these ionic compounds, because when the ions come together, it has to have it has to be neutral. Now, here's the trick. All right, and it's not a trick. I don't even want to use the word trick because then you think I'm doing some kind of magic. Here's the math shortcut. So I didn't make it up. It's called the crossover technique. And what you do is to figure out how many of each ion you need to balance it, you look at the opposite charge. So for example, barium, I want to know how many bariums. I look at the charge, the opposite ion. So bromide has a 1, I need 1 barium. Then for the other one, how many bromides do I need? I look at the opposite charge. So I need 2 of them. Now, what I want you to understand, I'm not dropping charges. I'm not switching charges. I'm doing nothing except using the numbers on the charge to figure out how many I need. Next, let's look at this. Let's dissect the next one. So for potassium, I look here and I need 3. For the nitride, here, I look here and I need 1. I don't write the 1. So what I'm doing is I am looking at the opposite charges. I'm not moving the charges. I'm not flipping the charges. There's no charges in the bottom. The charges are just numbers. I'm using those numbers to solve the math for me quickly. So the aluminum oxide, I get aluminum. I'd say, how many do I need? I need 2. So I write the number 2 there. Look at the oxide. Look back here. How many do I need? 3. I write the 3 there. Okay, I'm going to write a couple more examples on this page, and then I have a couple. If you've got it, you've got it. All we're going to do is practice now for the rest of the video. But if you don't have it, stay around. We'll do a couple more. So let's say I have magnesium and chlorine. No, I want to do a different one. Magnesium and I can do chlorine. Okay, you try. Pause so you have a time to finish. Okay, so magnesium, I would need 1. Chloride, I would need 2. Let's do another one. Let's do cesium and sulfur. So try that one. Pause. If you don't have the answer, I'm going to give the answer. So cesium, I would need 2. So you look at the opposite. Sulfur would need 1. This would be named cesium sulfide. And I know the ions because I'm using the periodic table. So that's how I know the charges. So you would be able to use the periodic table, to figure out the charges. All right. So let's go back, and I'm going to have a few more practice for you to try. Okay, I think that's where I saw, because I skipped ahead. Okay, so here's a multiple choice question. Why don't you pause it, try to get the answer, and then unpause it, and I will do the answer. Okay, so this says, what is the formula for the compound formed between potassium and sulfur? And so in order to solve this problem, first you have to get the ions. So you would use the periodic table. You could see potassium, which is K, is in group 1, so it's a positive 1. And then sulfur is in group 6A under oxygen, and those are negative 2. So there's the ions. And then to put them together, we know the charges need to be equal. So looking potassium, since sulfur has a 2 negative, it's going to require 2 potassium. And then since potassium has a 1 positive, it's going to require 1 sulfur. So you can look at the opposite charges, the charge of the opposite ion, to determine how many of that particular ion you're going to need so that you get a neutral charge. And so the answer here would be letter C. And its name, just to keep practicing, is potassium sulfide. Okay, let's do the next one. All right, so they gave me the name magnesium nitride. So I know the two elements involved. So pause it now. You're going to want to get the ions and then figure out the formula. Pause it and then come back and I'll have the answer. Okay, so magnesium is Mg. It's in group 2A, and the alkaline earth metals, or group 2A, have a 2 positive charge. Then nitride is the anion of nitrogen. And nitrogen's in group 5A, and group 5A we predict with the octet rule a 3 negative. So to get the formula, so for how many magnesium, you look at the nitride, and since that has a 3, it would be Mg with a 3. And then the nitrogen, you look back at the magnesium, and that would require 2. So that answer is also letter C. And the name would be oh, we already know the name because that's how they gave it to us this time. This is magnesium nitride. Okay, I have one more to try. What is the formula for barium oxide? Okay, pause, try to get an answer, and then unpause and I'll do it. So if they give you a name or names of elements, we have to know the charges to get the formulas for ionic compounds. There's not really another way. So I would say barium, that's an alkaline earth metal. That's group 2A. So they have a 2 positive. And then the oxide is the anion for oxygen, and it has in group 6A a 2 negative. Now, I always throw this one at the end. I go back to our first practice, and this is a 2 positive and a 2 negative. When the charges have the same value, no matter what the charge is, a 1 and a 1, a 2 and a 2, a 3 and a 3, if they have the same value, it's always a 1-to-1 ratio. So the answer to this one was letter A. Now, learning to write formulas of ionic compounds, it can be a challenge, but it is worth investing your time in because as we proceed in the course and learn new things, we will be writing ionic compounds. We'll be having to look at them and know what ions are there. And so it is an important thing, not just for this chapter, but for future chapters. So it's worth practicing. And always feel free to ask questions if you need clarification or if you're working on something and you're not sure how they're getting the correct answer.